thanks for joining this expert class. My name is Luc Jacobs from Flanders Make, and I'm going to try to take you through the whole process from design to manufacturing, because that's what we do. We are working on about every step between the initial product idea and the shipping of the products. Maybe first a word of introduction for those who don't know us. Flanders Make is a research institution. It's one of the 4 strategic research institutions in Flanders. We have 850 researchers, and our only task is to help the Belgian or the Flemish manufacturing industry with innovation and also with the digitalization of their manufacturing processes. So we have a lot of people. That means that we also have a lot of projects. So on average, we have about 300 ongoing projects in the most diverse topics, like, for instance, electrification of vehicles, drones for warehouse inventory, 3D printing of small parts, automatic vehicles, photonics, exoskeletons, you name it. If it touches the industry, probably we have researchers who are working on the topic. Today, I'm going to talk about 4 challenges that we often see in the whole design to finished product process. And the first challenge that we see is silos in the organization. So you have a design department, you have an assembly department, you have manufacturing, you have shipping, you have quality control, and so on. And often, they don't know each other too well. They don't know exactly what the other's job is. Certainly, if you have new people, they don't know it. And if you have a large organization or if you are on multiple sites, then this is also typically a problem. So this also has the consequence that designers sometimes make decisions in the beginning of the process that have negative impact on the rest of the process. So we are trying to help them avoiding this. Second challenge is new inexperienced people. You know that it's hard enough to find people at all. It's even harder to find experienced people. So you have to do with people that you find. You have to get them up to speed, and you have to avoid that they make the same mistakes as the other people have made when they were young. So this is as well in the design department as in the manufacturing department. So we try to anchor the knowledge in the experienced people's head in tools that the young people can use to get up to speed quickly and to avoid mistakes. The third challenge is nowadays, with all the new technology, we have a lot of product variation. So we have customers who have 40, 50 different variants on the same assembly line, which is, of course, a challenge for the operators. It's very easy to take the wrong sensor and put them in the wrong product, which then leads to a rejection in the quality control. And all this is costing you a lot of time and quality issues. So we have to do everything we can to avoid that. And last but not least, there is a digitalization hurdle. Everybody is talking about digital transformation, and it's very nice. But between the old process and the new process, you have an extra hurdle, which is that you have to continue the old process and invest money and effort in the new process. So this is also something that stops many people from doing it now. It's say, okay, we'll do it next year, or we'll do it at another time. So also there we have thought, how can we help industry by making this easier? So if you see the whole process between the product conception and the shipped product, we have defined a number of steps where we think that we can bring some help to the industry. So at the top you see the whole design process. At the bottom you see the whole manufacturing process. Maybe can I ask you just a raise of hand, who is more at the top at the design process in your organization? Okay, that's about half. And who is more in the manufacturing process? Okay, more in the design, but still, okay. So we are trying to optimize this process to avoid errors and to help you digitalize easier and faster. And to do this, we say you don't have to start from scratch every time. There is something that you already have, and those are your design files, the files from your CAD system. So we always going to, in each step that you see here, we will go and reuse those existing files to digitalize your process. But even before you start designing, you have to see how does my new product idea fit in my product family. So there it's important, does it have the right price, does it have the right performance, and does it fit the family? So today, this is a lot of gut feeling. I just want to give the message here that we also have developed tools to objectify this process and to help you make the right decisions there, which impact the whole rest of your process, of course. But let's start with the design. So we do not make CAD systems. You have your Siemens NX, your SolidWorks, or your Inventor, or whatever you are using. So you keep on using that, and what we do builds on those existing tools. So first of all, you have the design phase. There we are currently starting 2 research projects. I see you taking pictures. At the end, you have a QR code to download the presentation, so it's up to you. The design process, the first project that we want to start now is parametric CAD designs. So what typically happens is if a designer designs something, they make a fixed design. This is so many centimeters, this is so many millimeters. You have a gear with 60 teeth and so on, and this is all hard-coded in the CAD design. Why do they do this? Because it's faster than to work with parameters. So unfortunately, it's done a lot of the time. So what we are starting here is a research to create an AI system to help you create parametric CAD designs based on product concepts. I'm not going into more details here because it's not there yet, but if it interests you, we can talk about it afterwards. And the second new research is also a tool that will help you, that will use AI to help the designer reuse old designs that were done in the past. Because if you have a designer who has been working for 10 years for your company, they know what has been done. If they have a new project, they know I can reuse this from 5 years ago. But if you have new people, they don't have that knowledge. And they don't have any tools to see, has it already been done? Or something similar been done? And they start reinventing the wheel from scratch. So also here we will use AI to see what they're doing, look in the past designs and propose them designs that they can reuse to go faster. So these are 2 new design research projects, but also important is you design a new assembly. You have different components that need to be manufactured for the first time that are specific. You can have a plastic housing, which needs to be injection molded. You can have other types of plastics. You can have metal sintering with 3D printing. You can have whatever. And you need to make sure that what the designer designs can be manufactured. Let's say you have 5 different components, a few injection molded, a few 3D printing. What typically happens, you send those designs to your suppliers to ask for a quote, and you send every design to 3 different suppliers. So that's 15 emails that you send out to ask for quotes and to ask for feedback. And then the next week or 2 weeks, you don't hear anything anymore. They are working, they are looking into your design, back saying, okay, this cannot be done in injection molding, you have to change this in the design, or will go badly in 3D printing. And then everything goes back to your designer, and they start again adapting the product. So we thought this can be done better, and we have created a tool that will put all this knowledge that are in your designers' heads, the experienced designers, and also in your suppliers' machines. We put everything in a tool, and you see at the top the different manufacturing methods, hydroforming, metal powder sintering, and so on. You see the different machines, and you see the different materials. And this tool allows you to upload your CAD design, and it will look per part, okay, this production method is being used, what needs to be changed, or is it okay, or do we need to change something to make it manufacturable? So you can already do the checks in your company instead of waiting for your suppliers. So how does it look like? You see your design, and we show in the red zones what cannot be produced or what will not go well, where the design needs to make adaptations. And they can do it right from the start. Also, if you are, let's say, an injection molder or a parts manufacturer, you could also give this to your customers to let them do the simulations instead of always taking their requirements, sending it to your injection molder or to your mold builder in China and ask them to do an analysis. You can have your customer do it yourself and save a lot of time and give your customer feedback the same day instead of 2 weeks later. Now we are continuing on this research, so what we saw now is the question, can it be manufactured? That's important to know, but it's also important to know the cost. Because I can define a metal sheet, I can define difficult bends, it can be manufactured, but maybe it's very expensive. So we also want to put that knowledge at the fingertips of the research, of the designer. So it will be similar than what you just saw, but we will not only say this cannot be designed, but we will also say, okay, you choose some rip here, it can be done, but it will be expensive. So maybe you should choose a less expensive method. You can compare this to a spell checker in Word, but for CAD design then, where we immediately do the necessary adaptations. The next question, okay, we know it can be designed. We have the manufacturers. Now the question is, can it be assembled? I'll give all my parts to the assembly department. Can they really assemble this correctly? How do we do this typically? The designer designs an assembly. They go to an assembly checklist. They see, okay, can every screw be reached with a screwdriver and things like that. They have internal design reviews. But we see in complex assembly, they always miss things. So after the design, you order all the parts from your different manufacturers or new parts, and only when those have been delivered, you can do physical assembly testing. So you can then do manual testing or robotic testing, and only then you see, oh, okay, I can reach everything, but this screw is here behind the back. This is hard for me to reach, and this you cannot see in your CAD file. Or the assembly falls over because all the weight is on one side. You can't see that in the CAD file. So what we are doing now is, instead of waiting here to the end of the process and then iterating all the way back to the beginning and then starting the whole chain of events again, we have created a tool where you import your CAD designs, and the tool will automatically check against all those rules, and it will tell you, okay, you have to change this and this and this because you cannot reach something, or it will be too heavy and fall over, and you can change it immediately in the design cycle and not go to the whole design assembly cycle. So these are some checks that the tool does. You can see this in the handouts, so I'm not going to go into details here. And then the next question, of course, is also like with the manufacturing before. It can be assembled. It's all very well. But this is the most optimal assembly sequence. So we are also working now on a research to automatically define the best assembly sequence in your manufacturing. So you upload your CAD design, the system will go to work and say, okay, with your assembly system in your company, this is the optimal design. Here you can follow two different paths, then you can bring them together again, and this will be the cheapest sequence that you can have. This will save you time initially after the design because you don't have to do it manually, but it will also save you time during the next 5 years when you are manufacturing that product, because every product will follow the optimal cycle here. Also for metal parts manufacturing, we are currently creating tools. First is for CAD/CAM. So if you have a metal part that has been designed and you need to have it machined, milling or turning or whatever. So today you ask again your internal workshop or your supplier for a quote, and there you need a competent person who knows, okay, what is my machine park, what is difficult in this design, and what is my experience from the previous years. So what would be the optimal cut pattern or cycle to do this? But if you don't have that experienced person, if they are ill, for instance, or they left your company, then you have to do a lot of trial and error with new people to get this right. So also here we are doing AI-assisted CAD/CAM configuration. So we want to have an AI system that reads the design file, that looks in the history of the company, and that looks at the machine park, and then will automatically suggest something, where then the operator can still say, okay, this is good, or I want to change something. They still have the freedom to do that. And the next research builds on the previous presentation from ARC-NC. We also have used 2 of their images, so we want to automate also the robotic welding. Not only the welding, but also the programming and the quality control of the system. So the research, the project will import the CAD file, will automatically find the weld lines and the weld parameters, will configure the robot, will use sensors to monitor the process, and at the end of the process it will do quality control to see if all the welds have been done well. So this is, I think, that RKNC, I don't know if you're talking to them, but I think so, and we are still open to other partners as well to join this research. So everything is there, all the parts, all the design, all the checks have been done, and now we give everything to the assembly department. Please assemble my product. So there we see that it gets difficult if you have 50 different products on an assembly line. We see a lot of mistakes, and we see not enough tools to help the people. So ideally, you would have digital work instructions, and even to that level that you get one variant 15 of a product, and that you automatically get work instruction 15 on the screen next to the operator to always give the right instructions for the right variant. Maybe a question, who here already uses digital work instructions in the company? One. Who does not? And can anybody tell me why not? But there's a lot of noise here, so it will be difficult, I think. Okay, anyhow, we see that the biggest reason why it's not there yet is, first of all, maybe the hardware is not there yet. There are no screens, but that's easy to solve. But it also takes a lot of time to make these instructions. And if you have 50 different product variants, what many companies say then, okay, I take the 20% products that make 80% of the sales, and for those products I make work instructions. It should be the other way around, because the products that are produced every day, all the operators know them well enough. It's the 80% of products that are not sold a lot, that are not known, and where everybody says, I don't have the time to make work instructions for these small batches, so I don't do it. So there we have created a technology framework for operator support, and we help the companies by, again, taking the files from their designers and automatically converting them to digital work instructions. So you don't have to do all the work manually. And even if you have a product family, like 50 different variants, we do this for the whole product family, so you only have to do it once yourself. We output a kind of XML file that then can be used again and again for different systems. For instance, you can push that file to the different systems on the Belgian market, like Azomuta or Proceedix or others, so that you don't need to do the authoring in those systems. It's automatically done for you. And if you already have done things in the past, like Word or Excel or PowerPoint, we have also made an importer that can import those existing work instructions and then can push that to the digital work instructions. So how does it look like? Well, we import the files from the designer. The system will automatically propose a feasible assembly sequence for that product. You can change it manually. You can say, no, I want to do this first, no problem. And then it will automatically generate the images or videos for each step with the right viewpoints for an operator. You can still annotate it. You can say publish, and it's automatically pushed to the different systems. So this way you can really make work instructions very fast for one single product here. And if you have a lot of variants, like here 50 variants, we create a knowledge graph with all the different components of each variant. And for each component, you only make the work instructions once. And then the system will automatically create the right sequence for every different variant of your product. So here you can really have the situation that product comes in front of the operator, and automatically the corresponding work instructions also come there. And you can use this now in the assembly, but you can also use it in testing. If you say, I want the right test sequence for every different variant, we can generate the right test sequence for the different variants as well. So we've tested this with Picanol on 50 variants, and it saved them 96% of the time. So it's a factor of 20 or even more that it goes faster than the manual way. The training part, you have to train existing people on new products. You have to train new people on existing products. So how do we do this? We are now seeing that AR and VR, this augmented reality, really bring advantages. It looks like a gimmick, but it's not, because we have done tests with that, and we see that there's really a reduction in the error load, and that it's faster training as well for the people. Only thing here is the same. It looks very difficult. I I have to buy an augmented reality tool, and then I have to create a lot of different steps manually to show this to the operator. No, this is not necessary. We have extended this platform so we can also push the XML files to AR or to VR, which really reduces the authoring time. We've tested it, and for one product, we could do it in one day, create a complete augmented reality instruction, which you can see in our booth over there, how it works. You have to handle products if you use robots or cobots. I'm not going to go into detail, I don't have the time, but the challenge there is you have a lot of robots, but you even have more grippers. So there's thousands and thousands of grippers on the market. You have to choose the right one. We have tools that do that for you. So you have a choice of out of 5 grippers instead of 6,000, 7,000, and then you can choose the most cost optimal one. Then you still have to design your fingers for the grippers for specific products. So there we're going to look again at your design file automatically, see where we can grip the products or the different product families, and then we will propose a gripper design that you can use quickly. I'm going to go over this. And then, I guess that nobody here ships products without quality control. I hope not. So what we see today for quality and control, we see a lot of AI vision systems that are being used, and this is really useful. It works very well. So you have a robot, a camera that checks for defects, that checks for tolerances up to a few micrometers, so that's all very nice. The only problem is that you have to train AI vision systems, and that's the challenge. If you are inspecting apples, you can buy thousands of images of apples that are already annotated. This is a green apple and it's good. This is a red apple, it's not good. This is an apple with a wormhole in. So you can buy those images and you train your AI system. That's nice. But here, of course, you have your products. Nobody knows them. You cannot buy any images. You have to make them yourself. And that's the work here. That's the challenge. So typically, you would have to take thousands or hundreds of maybe thousands of pictures like this, and then you have to find somebody who is willing to spend a few weeks for every picture to define, okay, this component is that component is that, and do this manually, and then you can train your AI system. So nobody likes this. It's also very expensive, and it's a hurdle. So there we have created a pipeline which automatically generates those images for you. So we take your design files again. Oops, this is the wrong. We take your design files again. We automatically generate images using a game engine, but these are really photorealistic images. We automatically annotate them by the computer, not by a person, not by a human. And then automatically you have images that you can feed up to 200 times faster. You can feed to your AI system, and you can start picking products from a bin or recognizing products on a conveyor belt. So we also do the AI itself, but we certainly do a lot of AI training optimization with this. You can use it also to detect defects. You don't have to wait until you have 500 products with a defect. We generate automatically synthetic images where you see defects, where we generate defects, and you have immediately enough images to train the AI without needing the physical products with defects to do so. Or you want to inspect a product from different angles because you need to measure tolerances, or you have to look into a hole. We take the CAD files, we define the robot parts, and we automatically make sure that all the right viewpoints are being used. So to summarize, we have seen the 4 different challenges. I think that we addressed them. So the silos we break down by giving the designers tools that also take into account the rest of the manufacturing process. So they can make the right decisions already in the design phase that lower your costs or your errors further down the line. So for the new people, we put the knowledge of the existing people in tools, and we give those tools to the new people. You can train them faster, and you can make sure that they don't make the same mistakes that people have made in the past. We support product variability from the conception over the assembly until the quality control. All our tools allow for product variability and handle many different versions. And last but not least, the digitalization hurdle. So I showed that you don't need to start from scratch. For every step, you use the files that you already have. You don't have to do everything manually. We generate a lot of things automatically. And it's good to know that also to address this hurdle, there are also financial support mechanisms, which we can talk about at our booth. So sometimes we can also help you find some money to test digitalization.